All right, so this is our lecture on impulse. Yesterday we worked on momentum. So what is impulse? So it's symbolized with a capital J for some reason. And impulse, capital J, equals force times a change in time. So impulse is the product of the force acting on an object over the time during which the force acts. That's the fancy term for it. The unit is newtons times seconds. So obviously the unit for force is newtons, and for time, it's going to be seconds. So this right here, you're probably thinking, what's going on? Why do we see an image of Muhammad Ali and it says top 10 knockouts by Muhammad Ali? So what is this? Like, how does this relate to, how does boxing relate to physics, and specifically this term called impulse? So, excuse me. So I'll post a link for this as well, or we can watch it in class. It's up to y'all. So why is boxing an example of impulse? So impulse, well, you know what boxers, you've seen what boxers look like. Boxers, they use boxing gloves, etc., blah, blah, blah. So the padding in the gloves increases the time it takes the fist inside to stop. So assuming you're throwing consistent punches the whole time, if a hand is gloved, it will take a longer time for it to stop, resulting in a lower force. If you threw that same punch without the glove, the shorter stopping time, with that person's face probably, or body, whatever, would result in an increased force. Therefore, you will have more damage to the face or body part, whatever, because the stopping time is way less. Okay? So if you have the same force over a longer period of time versus a shorter period of time, notice how, again, let's say impulse, force times time, and they're consistent the whole time. If you increase that time, your damage will be less. But if you have a greater force over a shorter amount of time, that impulse or that damage will be a lot greater. So you're standing in a cave with icicles when a huge one breaks off and hits you, imparting a force of 3 newtons for 10 seconds. 0.10 seconds, I'm sorry. What is the impulse? Again, identify J, force, and time. So your impulse is your force times time. So 300 newtons times 0.10 seconds. So 300 times 0.1, it's going to be 30 Newton seconds. So what is the relationship between impulse and momentum? It's in the impulse momentum theorem. So you'll notice how this kind of all equals each other. So the impulse or the change in momentum is the same thing. So notice the change in momentum, change in P, is mass times the change in velocity, which is also over here too. So all of this equals each other. So technically you could have a problem where you have your force times time equals your mass times the change in velocity, or maybe this is the force, this is the time, solve for the final velocity, for example. So you have different combinations you can have with this particular theorem. If you apply a force on an object, it will gain some momentum. If an object that loses momentum must be imparting the force to something else. So basically, your momentum is conserved throughout this whole system, if you will. So the thing with impulse is that it's important to be mindful of be mindful of the time duration. So one thing we have to be mindful of with this theorem is that the force imparted on a moving object, when it strikes some surface, it will be large if the time you're staying on that particular, in that time you hit it. If it's a short amount of time, the damage, if you will, the impact will be greater if you spend less time. The more time you spend in that particular motion, in that particular force, the less damage will be done. So for example, if you fall, let's say you jump off the roof of something into a trampoline, that force is kind of extended over a longer duration of time. Therefore, the impact will be lesser if compared to jumping off the roof and hitting the ground itself, because that force is kind of done instantaneously as opposed to expanded or prolonged over time. So my baseball players, some of y'all are out there. So I'm not a baseball player or a coach, obviously, but knowing physics, baseball players, they're taught to swing through the ball as opposed to stopping when the bat makes contact with the ball. By maintaining that contact between the bat and the ball for as long as possible, you end up with the maximum possible force that is imparted on that ball. I think this is a better better swing, so to speak, compared to the other one I showed you in class last semester. Example number 5. A baseball has a mass of 0.10 kilograms and has a speed of 20 meters per second as it flies towards a batter. The batter hits the ball and sends it in the exact opposite direction with a speed of 22 meters per second. Calculate the change in the ball's momentum. You're given speeds, not velocity. Since the batter hits the ball and sends it in the opposite direction, we need to make the final velocity negative 22 meters per second. So we have a mass. We have some, let's say if I want to make my final velocity negative, my initial velocity is going to be positive because they're coming in opposite directions. So remember that your change in momentum, change in P is mass times your change in velocity, or my final velocity minus my initial velocity. So what is my change in momentum? My mass, 0.10 kilograms, times negative 22 meters per second minus 20 meters per second. I'm going to end up with my change in momentum. So I have 0.1 times negative 22 minus 20, so negative 4.2. Negative 4.2 kilograms times meters per second. All right, so that's it for now. So if you have any questions, please let me know and hit that like and subscribe. Bye.